Hello friends, today we are going to see some more topics in our chapter, that is generics. So let's start with the bounded wildcards. Wildcard arguments can be bounded in much same way that a type parameter can be bounded with upper limit, like we number class. A bounded wildcard is especially important when you are creating generic type that will operate on a class hierarchy. To understand why, let's work through an example. We will see one example, and this example is hierarchy of classes that encapsulate coordinates. Two-dimensional coordinates, class 2D, integer x comma y, a and b parameterized constructor is there, 2D. X is initialized with a, y is initialized with b. Then class 3D extends 2D. So there is one more class 3D. It will extend 2D integer g, and it is calling the super constructor for the base class constructor calling, and z is initialized to c. Then class 4D extends 3D. It is multi-level hierarchy. 4D integer a, b, c, d, super with a, b, c, and t is initialized with d. At the top of hierarchy is 2D, which encapsulates a two-dimensional xy coordinate. Okay. So 2D is a basic, x and y is compulsory coordinate. So 2D is a base class. Then 3D, 2D is inherited by 3D, which adds third dimension, creating an XYZ coordinate. 3D is inherited by 4D, which adds fourth dimension time, yielding a four-dimensional coordinate. Okay. So 2D will add one Z coordinate, XYZ coordinate, and 3D is inherited by 4D, and it adds a fourth dimension that is called as time. Shown next is a generic class called coordinates, which stores an array of coordinates. This class holds an array of coordinates object. Class coordinates T extends to D, T array coordinates. It is initialized with T array object coordinates is equal to O. Notice that coordinates specify a type parameter bounded by 2D. This means that an array stored in coordinate object will contain objects of type 2D or one of its subclasses. Okay. The type parameter bounded by 2D. So whatever T will be there, that will be either 2D or the subclass of 2D. So that's why we have written over here T extends 2D. This is the bounded wildcard. This means that any array stored in coordinates object will be either 2D or subclass of 2D. Now assume that you want to write a method that displays the x and y coordinate for each element in the coordinates array of coordinate object. Because all types of coordinate objects have at least two coordinates, that is compulsory, x and y. This is easy to do with a wildcard. We will see now. Coordinates with question mark. Okay. And this is a wildcard. So question mark is there, and upper limit is what? Our 2D class. So other than 2D class or its subclasses, we cannot write anything over here. So this is the method we have created, a show xy coordinates. For integer I is equal to 0, I less than c dot coordinates dot length I plus plus, c dot coordinates of I dot x plus space c dot coordinates of I dot y. So what we are doing over here, we are doing the x coordinate and y coordinate in the coordinate array. Okay, so c dot coordinate, whatever coordinate object we will having, its array we are fetching over here, and for that array's length we are iterating this for loop, and we are displaying the x and y coordinates. Because coordinates is a bounded generic type that specify 2D as upper bound or upper limit, all objects that can be used to create coordinate object will be array of type 2D or of classes derived from 2D. Thus, show xy can display the contents of any coordinate object. Any object that you will specify over there, that will be wildcard, that is the first type. First condition, it is wildcard, and secondly it is a bounded wildcard. So whatever data type will be there, that will be of 2D or any subclass of 2D. However, what if you want to create a method that displays the x, y, and z coordinate of 3D or 4D objects? Not all coordinate objects will have 3 dimensions because coordinate 2D object will only have x coordinate and y coordinate. Therefore, how do you write a method that displays x, y, z? We will see now. For coordinate 3D and coordinate 4D objects, while preventing that method from being used with coordinates 2D object. Okay, so how we will write that whatever method that we are creating, that method should not be used with coordinate 2D. It will be only used with either 3D object or 4D object. The answer is bounded wildcard argument. A bounded wildcard specifies either an upper bound or a lower bound for the type argument. This enables you to restrict the types of object upon which the method will operate. The most common bounded wildcard is the upper bound, which is created using extends clause in the much same way it is used to create a bounded type. We will use the extend keyword. Using a bounded wildcard, it is easy to create a method that displays x, y, and z coordinate of coordinate object if that object actually has those 3 coordinates. The following method we will see. Coordinate wildcard extends 3D methods shows the x, y, and z coordinates of the elements stored in coordinate object of those elements are actually type of 3D or are derived from 3D. So now coordinates question mark extends 3D and object name is C. X, Y, Z coordinate. For this type, this way we are iterating into the for loop. C dot coordinate of I dot x plus C dot coordinate of I dot y and C dot coordinate of I of z. So for that I, for each and every array elements XYZ coordinate we are displaying over here. An extends clause has been added to the wildcard in the declaration of parameter C. It states that the question mark can match any type as long as it is a 3D or a class derived from 3D. Okay, so upper limit is 3D. Thus, the extends clause establishes an upper bound that the question can match. This bound show XYZ can be called with the references to object of type coordinate 3D or coordinate 4D but not with the reference of type coordinate 2D. If the upper limit is 3D, it cannot go above the 3D. That is, it cannot go to 2D. Okay. Attempting to call show XYZ with the coordinates to reference results in a compile time error in this method, thus ensuring type safety. Here is an entire program. We have combined bounded wildcard, 2-dimensional array integer xy, a and b parameterized constructor. Then 3D extends 2D. It has one more parameter z. 3D with a, b, c parameters, super a, b, and z is equal to c. 4-dimensional coordinate. 4D extends 3D integer t, 4D a, b, and c, d. Super a, b, c, t is equal to d. Now class coordinate t extends to d. T of coordinate t array object. So object of this type t and which will be extending 2D. So upper limit is 2D. Now bounded wildcard method. In bounded wildcard we are creating a method called show xy coordinates question mark c. XY coordinates C dot coordinates dot length we are displaying X and Y. Then coordinates question mark extends 3D. So for show XY, the upper limit is nothing because above 2D there is nothing. So question mark is only there. It is not like extends. Question mark extends 2D. It is only coordinates question mark C. Here it is upper limit is 3D. This method should not be using the 2D class. So it is question mark extends 3D and object name is C. Here we are displaying XYZ coordinate. Then C dot coordinates dot length. We are iterating through this for loop. X, Y, and Z will be displayed. Then void show all coordinates question mark extends 4D and object name is C. We are displaying over here X, Y, and Z coordinate. Now in public static void main. New 2-dimensional 0, 0, new 2-dimensional 7, 9, 18, 4, -1, -23. Now coordinate 2D object is created and it is passed with TD. Okay, so this TD array, two-dimensional TD array is 4 elements. It is passed over here. Then contents of TD log. Show XY. It will show all the elements. These elements 0, 0, 7, 9, 18, 4, minus 1, minus 23. Okay, it is a 2D. Okay, so show XYZ TD logs will not be possible because for show XYZ upper limit is 3D. For show all upper limit is 4D. Then now create some 4D object. Four 4D objects are created and it is stored in the 4D object array. And here also new object of coordinate is created and this 4D array is passed over here, FD. Okay, then contents of FD logs, and here all the method calls are okay because for show XY upper limit is 2D, it is allowed because above 4D there is 3D, above 3D there is 2D. Then show XYZ, its upper limit is 3D, above 4D there is 3D available, so you can work with this. Then show all FD logs, it is a 4D itself, so upper limit is 4D, so you can go with this method. Output is contents of TD logs, the 4 elements first 0, 0, 7, 9, 18, 4, minus 1, minus 23, and contents of FD logs 1, 2, 6, 8, 22, 20, 22, 9, 3, and minus 2. Then XYZ coordinate 1, 2, 3, 6, 8, 14, 22, 9, 4, 3, minus 2, minus 23, and XYZ and time coordinate 1, 2, 3, 4, 6, 8, 14, 8, 22, 9, 4, 9, 3, minus 2, 23, 17. This command outlines. So this, if you will uncomment these lines, your program will crash or it will give you error. Because TD logs is a coordinate 2D, it cannot be used to call show XYZ or show XY all because the upper limit is 3D and 4D respectively. To prove this to yourself, try removing the comment and it will give you compile time error. Okay. In general, to establish an upper bound, use the following type of wildcard expression. Question mark extends the superclass. Okay. So above that superclass, your call will not go. Where superclass is the name of the class that serves as the upper bound. Remember, this is an inclusive clause because the class forming the upper bound that is specified by superclass is also within the range of the bound. You can also specify a lower bound for which wildcard adding a super clause to a wildcard declaration. Question mark super subclass. Okay, so it will give you the lower bound. Question mark super subclass. Only classes that are superclass or of subclasses are acceptable arguments. Only classes that are superclasses of subclasses are acceptable arguments. This is an exclusive clause because it will not match the class specified by the subclass. Creating a generic method. At the preceding example, we have seen methods inside a generic class can make use of class type parameter and therefore automatically generic relative to the type parameter. However, it is possible to declare a generic method that uses one or more type parameters of its own. Okay. We have seen methods inside a generic class can make use of class type parameter and are therefore automatically generic relative to that particular type parameter, and it is possible to declare a generic method which is separate method that uses one or more type parameters of its own. It is possible to create a generic method that is enclosed within a non-generic class. So for generic method to be present, it is not compulsory that class is also generic. Let's begin with an example. The following program declares a non-generic class called generic method demo and static generic method within that class called isLn. Generic method demo is non-generic and its method is generic. This method determines if an object is a member of array. It can be used with any type of object and arrays as long as the array contains objects that are compatible with the type of the object being sought. So we will see the example class generic method demo. Determine if an object is an array. Static t, v extends t. Boolean is ln tx v array y. So whatever object that we are passing, it's an array or not. We are checking it. For integer I is equal to 0, I less than array's length I plus plus, iterating through the y array length. If x equals y of I, so whatever x element that are of type T is equals y of I, any element of the I, any element of the y array, it will return true, and it will otherwise it will return false. Okay, so any element in the array is equal to the element that we are passing as an parameter. It will check for the equality. If it is present, it will return true, otherwise it will return false. Now, integer numbers array is there 1, 2, 3, 4, 5. So is in, it is not is ln, I'm sorry, is in 2 comma numbers. So in numbers array, if 2 is present, 2 is in numbers will be displayed. If not is in 7 numbers, 7 number is not present in the numbers array. Okay, so use is in on string 1, 2, 3, 4, 5. If is in two strings, so 2 is, if 2 is present in strings array, it will give you 2 is in string, otherwise it will not give, it will give you 7 is not in string array. Okay, so if it is in incompatible types, so it will give you if is in 2 comma numbers, 2 is a string and numbers is a number array, it will give you 2 is in string, it is a wrong method declaration. So this will not compile, it will give you compile time error. So 2 is in number, 7 is in not number, 2 is in string, 7 is not in string. First notice that how it is declared by this line. Static t comma v extends t, boolean is in t x v array y. The type parameters are declared before the return type of the method. Okay. And second, notice that the type v is upper bound and upper bounded by t. Okay. So whatever type that you are specifying over here, so its type must be of type T. Okay. Thus, V must either be of same type of T, otherwise greater than, or sorry, subclass of T. Okay. This relationship enforces that is-in can be called only with the arguments that are compatible with each other. String and integer cannot be compared, that we have already seen in this example. Also notice that is-in is static, enable it to be called independently of any object. The generic methods can be either static or non-static. There is no restriction in this regard. So it is not compulsory that it is static or it is non-static. Notice how is-in is called with main by use of the normal call syntax without the need of specific type argument. So we will see how this call is-in is called. Okay, is-in 2 comma numbers, is-in 2 comma strings without the need of object. Okay, and also without the need to specify the type argument. Next, for example, this is because the types of the arguments are automatically discerned and the types of T and V are adjusted accordingly. Is in 2 comma numbers. The type of first argument is integer due to auto boxing, which causes integer for substituted for T. So you don't have to specify the type explicitly. The base type of second argument is also integer, which makes integer is a substitute for V2. The second call string types are used and the types of T and V are replaced by string. Now notice the commented out code is in 2 nums and 2 is in string. Because 2 is a string, it will not be present in a nums array because nums array is of integer type. And if you will uncomment this line, it will give you a error. The reason is that the type parameter V is bounded by T in extends clause in V's declaration. So T is a upper bound. Other than that, that upper bound, anything cannot be written over there. Okay, if the upper bound is, for example, integer, you cannot write a string over there. V must be either of type T or subclass of T. The first argument is of type string, making T into string, but the second argument is of type integer, which is not subclass of string. Okay, this causes compile time error, and this ability to enforce type safety is one of the most important feature or advantage of the generic method. And in this example, generic method were there without the use of generic class. Okay, so in non-generic class, you can have the generic method. The syntax used to create reasoning can be generalized: type, parameter list, return type, method name, parameter list. This is the generalized syntax of the generic method. Okay. Type parameter list is a comma separated list of type parameters, then return type, and then method name and parameter list. For a generic method, the type parameter list precedes the return type. Okay. So before return type, the type parameter list for a generic method only. Okay, this declaration is not for all types of method. It is just for sake of generic method. The type parameter list precedes the return type. For normal method syntax, return type will be the first in the declaration of method. Now we will see generic constructors. It is also possible for constructors to be generic even if their class is or not. For example, consider the program. Okay, if class is non-generic, its constructor can also also be generic. Its method can also be generic. Class generic constructor private double value T extends number generic constructor T argument. So what is this? Your constructor do not have any return type. So there is no return type. But what is this T extends number? It is a declaration and it is the indication that this is a generic constructor. So whatever T will be there, it will extend with the upper bound number and T argument. Parameter is also of type T. Value is equal to argument dot double value. Okay. So whatever argument will be passed over here, it will be converted to double, and this will be written in the value variable, and value is declared as value double, private double value. Then show value, displayed value. Then generic constructor test is equal to new generic constructor 100, then new generic constructor 123.5. Test dot show value, test2 dot show value. Output is 100.0, 123.0. Because generic constructor specifies a parameter of generic type, which must be subclass of number, generic constructor can be called with any numeric type including float, integer or double. Even though generic constructor is not a generic class, its constructor is generic. Okay, so how it is defined over here? Whatever argument that we are passing, it is of type T, and T is restricted with T extends number. So anything that you are passing to argument to the constructor, generic constructor, that argument must be of type number only. It can be integer, it can be float, or it can be double. It cannot be string, it cannot be boolean. So it is defined using this line: T extends number. So upper bound is number. Number is a class which have subclasses integer, float, and double. It does not have boolean and string. Okay. So this way we have seen the generic constructors also. So we have finished much more topics today in the today's session. In the next upcoming sessions, I will try to finish all the remaining topics of generics class, and then we will start with the practical part. So meet you in the next session. Thank you so much.